Alright, here is my controls project. It is a mechanically actuated AMBU bag. So there's a rack and pinion that I designed myself in this nice little cradle for the bag, and it compresses this bag to give air to a patient. So the parameters that should be controlled are the breathing rate, so the breaths per minute, which we can see if we decrease this way down. It's moving much slower now. Increase that back up. Oh, and if we surpass the maximum suggested of 19, so once we hit 20, you can see this light here turns red to warn us that we might harm the patient. And the tidal volume, so the amount it compresses the bag, is also adjustable. So we can see that if we decrease from 500 milliliters down to 200, that it's barely compressing at all. And those aren't accurate values, those are just based on a couple volumetric measurements. You can see the stats shown on the main screen here. Then that's the first Arduino, and the second Arduino is powering the ultrasonic distance sensor. So this is sort of just a conceptual thing. If the doctor puts their hand close to it, it'll stop it, so the person doesn't get their hand caught. And of course that messes up the syncing of the motor, but it allows them to take the bag out without hurting themselves. And so the inputs to the stepper motor driver, which actually drive the stepper motor, there are three. So the first one, the enable pin, is connected to the smaller Arduino and the ultrasonic, so that if a person puts their hand there, it triggers that and it turns off the motor. And the other two are the direction and the pulse, which are controlled with this Arduino as far as just how far the rack and pinion is moving and all of that, and how fast it's moving. And it takes in 10.8 volts, a little under 1 amp nominal, and that seems to be it, I think.